Today we will continue our discussion on the importance of fluid management. An important part of the fluid management conversation is how to set up a job site for success. How you configure the job site and stage your equipment influences overall HDD efficiency. Let's look at how you can successfully set up a mud reclaimer on an HDD job site. First, there's a number of different reclaimers out there, different sizes, but how do you choose the best mud recycling system?
Obviously, you need to look at the amount of volumes that you're going to be pumping and what your maximum output of your high pressure mud pump is. Obviously, you don't want to undersize your reclaimer compared to what the output of your mud pump is or what the output of the volume of fluid you're going to be pumping for the specific project that you're doing. Another important factor is, every reclaimer system has a specific processing rate, meaning, it can process X amount of gallons of fluid through the system. And again, that's something that you want to use kind of as a factor and how that compares to the volumes that you're going to be needed to pump on a specific project and the high pressure mud pump that you're going to be using on the project.
So we talked through, volumes, right? Volumes on either how much fluid we can recycle or how much the drill may need to pump downhole. How does access to water influence the setup of that reclaimer?
I think the access to water is minimal as far as choosing your location of your reclaimer, whether it's going to be on pipe side or you're going to be on drill side, because it's so much easier to pump clean, fresh water, even in a 2-inch hose. You can run a 2-inch collapsible hose a long distance. And if you have to run it even further, you can use an intermediate trash pump between the two lines. So that's not as important as where is my returns coming. So where is my fluid going to flow so that I pick it up and put it into my reclaimer is more important than where my access to water is.
Moving on here, can you provide any tips to minimize the transportation of drilling fluids?
What we're referring to there when we talk about transportation of drilling fluids is not transferring them to the dump site. We're talking about how do we transfer the returns from the bore path or the borehole back to the reclaimer if it's on the drill side or the entry side of the bore. Because once you start back reaming, your returns are typically going to go out the exit side of the borehole. So now you have the challenge of how do you transfer those cuttings and that drilling fluid back to my reclaimer. Typically what you see in the field today is they'll use vac trucks or tanker trucks. They'll suck the fluid up on the exit side, trip it around back to the drill side, and then dump it into a pit, and the reclaimer then will reclaim the fluid. Sometimes in certain situations, if you have the option to do this, some ways that you can eliminate all of that trucking or transportation time and cost is that you can pump it back to the entry side where the reclaimer is via a transfer line. Now, not every project is going to allow you to do that. So that's one method or way that you could potentially minimize the amount of transportation that goes on with moving fluids from one side to the other. Another example could be, the profile of your bore. If you're looking at a project that has a lot of elevation changes between the entry and the exit side, if you can set your drill up on the low side of that bore, your returns are typically always going to come back to your drill where your reclaimer is. And that's not always feasible. It's all going to depend upon, the layout and the structure of the right-of-way that you have to work with. But that is potentially another way that you can help minimize those transportation of drilling fluids.
Sure. One of the things I try to teach whenever I go out and set up a reclaimer for our customers, the first time they're using one, is always try to tell them that, it's always easier to transport clean fluid than it is dirty. As you're carrying those cuttings out with that drilling fluid, you create a lot of weight. Whenever I pick that up with a vac and I bring it back to my reclaimer on the opposite side, what if that volume of fluid is not recyclable? In other words, my driller pulled in too fast and didn't pump enough fluid. Well, then I have to work through that fluid in order to get to the next batch so that he can correct that flow. So if like Marv was saying, if I can pump it over, I know instantaneously what my fluid is looking like coming out from the other side. Or if I'm on the other side with the reclaimer, I can tell instantaneously, do I have the right solids to fluid ratios to be able to reclaim?
First, thanks for clarifying the transportation aspect of that. And then it also sounds like it's very important to, if we can determine where that entry pit is on the job site, we can potentially try to keep those returns coming to the entry pit rather than maybe going to the exit pit. But not all are controllable.
Nope.
On every job site. So, John, do you have any tips on helping a contractor reduce the risk of inadvertent returns?
Yeah, we kind of alluded it to many times during these conversations. Your liquids to your drilling fluid solids ratio, that is paramount when it comes to IRs. I mean, number one, we have to start out with the proper fluid for the soil conditions. I mean, that's the ultimate thing. Maintain the proper ROP, rate of penetration, and make sure that you're not what we call outrunning your fluid. So my solids to fluid ratio is correct. We're not outrunning our fluid, and how can we tell that? Well, we can weigh it. So, and the driller can sit there, or the mud guy can sit there and weigh the return fluid and be able to tell you what ratio of solids versus fluid that my reclaimer can handle. Maintain annular velocity also, is my fluid able to carry those cuttings out? Because if my fluid slows down, my solids are going to drop out. My solids drop out, I create a plug, which creates downhole pressure. And speaking of pressure, we need to minimize the downhole annulus pressure.
Whether you're running a reclaiming system or not running a reclaiming system, monitoring your returns that are coming out of your borehole are key, right?
Right.
Typically in a reclaiming system situation, you'll have somebody that's manning that reclaiming system, and he'll be responsible for doing mud weights or testing his fluids. Sometimes they might have a mud engineer on the job. But even if you're doing the pumping and dumping method, where you're just vacuuming up the fluids, hauling it off and disposing of it, monitoring that fluid that's coming out of the borehole just as a visual, keeping your eye on the returns to see if there's any drastic change. Does it look like it's getting heavier, or does it look like it's getting more, thicker returns that are coming? That can be a sign of, you're either not pumping enough fluid, your rate of penetration is too fast, So it's all about cleaning the borehole. And if you don't have the proper, combination of rate of penetration versus the amount of fluid you're pumping, it's going to result in higher mud weights and higher solid contents, which could eventually, lead to an inadvertent return. So,
I think it still kind of circles back to the fluid management is the lifeblood of the HDD operation. So even before we include some support equipment like a reclaimer, that initial mix, or how we create that right fluid that we're sending down hole, is ultimately going to be how we stay on the job site and continue to drill but ultimately reclaim it, right? We need the fluids to be able to continue to reclaim it, and if we lose those fluids, we're at risk of shutting down the drill or shutting down the job site until we can get those fluids back.
One of the things that I try to express whenever I'm setting up a reclaimer for a customer is I'll point to the operator of the reclaiming system, and I kind of have the driller with me, and I'll say, that guy's just there to push buttons. The driller is the one that is actually making that unit a success. So if his rate of penetration and his pump rate is not at an adequate pump rate or adequate volume, then you're not going to have recyclable solids coming back. So that in turn goes back to the IR question, everything else. I mean, that driller, the rate of penetration, how much fluid he's pumping is paramount in order for a successful bore and for the reclaimer to work well.
Thanks for tuning in for our discussion on job site success. That is all for this series on fluid management on your HDD job site. If you have further questions or are interested in fluid management equipment and how it can support your HDD job site, please reach out to your local Vermeer dealer or visit Vermeer.com.